Hello guys, let's start with another problem which is known as Armstrong numbers. Guys, first of all, I want to tell you that Armstrong number problem is also present at LeetCode platform, but it is only visible to paid subscribers on that platform. So that's why we are solving this particular this particular problem on GFG platform. Got it? So what is Armstrong number according to GFG platform? That you are given a 3-digit number and find whether it is Armstrong or not. An Armstrong number of 3 digits is a number such that the sum of the cubes of its digit is equal to the number itself. For example, 371 is an Armstrong number since 3 cubes is 9 plus 7 cubes plus 1 cubes is equals to 371. Okay. So guys, what is Armstrong number? Instead of only 3-digit number, if we want to calculate Armstrong number of any number size, what would be the definition of Armstrong number? It would be a number is said to be Armstrong if and only if the number of digits present in that number okay, whether it is 3-digit number or 4-digit number, if we take out each digit from that particular number and add it with the power of that particular number of digits, okay, then if it is equals to the number itself, it is known as Armstrong number. For example, here if I am talking about 153, what is the length of the number? That is the number of digits present here, that is 3. Got it? What is the Armstrong number? It is the power of each number to its length of the number. And if we add all like this, power to the length of the number, okay, to the given number, plus power to the 3 length of the number, what would be our answer? Cube of 1, that is 1. Cube of 5, that is 125. And cube of 3 is 18. What could be our answer? Our answer would be 153. Got it? This is Armstrong number. Here it is generally written that the number is of 3 digit. Okay, the length of the number is 3 digit. Okay, but it is not necessary that only 3-digit numbers are Armstrong number. There are many 4-digit, 5-digit, 6-digit numbers that are also Armstrong number. So we'll solve not only according to this question but according to the journal number. Okay, instead of only 3-digit number, we'll solve for general digit numbers. Okay, how we'll solve for this? First of all, we'll have to calculate the digits, the number of digits present in the number. Okay, how we'll do that? Calculate number of digits in a number. How we'll do that? Let's take duplicate 1 equals to n the number and duplicate 2 equals to n the number. Let's take sum also, because at last we'll have to calculate the power of each digit to its number of digits plus adding them all and checking whether it is equals to the num or not. number or not, that is n or not. Okay, so first of all we are calculating the power of the number of digits. So I will do that. Duplicate 1 until and unless it is not equals to 0. Okay, what we'll do, we'll just divide it by 10 and increment our digit sum. So let's take comma digit is equals to 0. Okay, digit will store the count, the length of the number n. Okay, now what we'll have to calculate, we'll have to calculate power of the number to its digit and add them all into sum. How we'll do that? We'll again make a while loop and check for duplicate 2 until and unless it becomes 0. Same thing, we have to first take out each digit from it by using modulo, and then we have to add into our sum math.var r comma digit, that is the length of the number n. Now at last we have to decrease our value of duplicate 2 by dividing it with 10. Got it? Now at last we have to check whether sum is equals to n or not. If it is, then we will return true. Otherwise we will return false. Here I am not using else condition because at last if it is not returning true, that means it has to return false because we have to return a boolean type. Got it? Let's try to compile and run it. Yeah, it is absolutely working for fine for 153. Let's try to submit it. Yeah, it is submitting. As I have already solved the question, so I'm not getting the marks, but yeah, it has been submitted. Got it? So what could be a time and space complexity? Guys, let's talk about the space complexity. Can you see? I had only taken couple of variables like duplicate 1, duplicate 2, sum, digit, like these. Okay. So what is my space complexity? It is big O of 1, that is constant. What about the time complexity? Guys, try to think about it. What about time complexity? Time complexity is big O of t. What is t here? What is d here? D is the big O of D. D is the digit. The number of digits present in n, which is actually equals to log of n with base 10. See, here I'm counting the number of digits. Here also I'm doing the same logic. It's just that I am summing the power of all the digits to the length of the number n. Yeah, these both loop are doing the same thing. So our time complexity is big O of digits, that is big O of log n with the base 10, because I am dividing each number by 10. Every time I am dividing each number by 10. So that's why it is logarithmically decreasing. It is decreasing logarithmically with to the base of 10. So hence our time complexity is big O of log of n with base 10, and our space complexity is constant, that is big O of 1. That's it. Signing off. Bye bye.